Greetings, M squared, and we're going to solve some more absolute value inequalities. These don't have the absolute value sign alone, so we're going to have to follow our steps. So we're going to get the absolute value alone. Once it's alone, we're going to check the right side for negatives, because those are some special cases if that happens, which I explained in the previous lesson, so you can go back to that if you want to hear a little more about that. We're going to remember that less thans mean and, so we have line segments when we graph them, and greater thans are ors, so we have two rays when we graph them. And these are the two inequalities, that you'd set up after you get the absolute value alone. We're going to solve and check and graph, of course. So let's go. We have the absolute value. We need to get it alone. We get it alone, we have to get rid of that -2, which was being multiplied, and the 10, which is being added. So we always get rid of, when we undo, we do the addition before we do the multiplication, because we're undoing, we're going backwards. So we minus 10 from both sides, and then we get a -4 on the right side. And it might bother us if this was alone, but it's not, so we just need to get rid of this -2. And when we do that, we just divide it by a negative number. We have to switch our inequality sign. So now our absolute value is alone, and it's time to make our two equations. So we say 3x minus 5 is greater than 2 for our first one, and then you'll notice we switch from a less than to greater than, so it's an or. And so we did this one. Now we've got to change the inequality sign and the sign of the number on the right side. So our second one is going to be 3x minus 5 is less than -2. So now we're going to solve. Plus 5 on both sides, and we get 3x is greater than 7. And when we divide, we get 7/3. So x is greater than 7/3 is one of our solutions. Now we're going to go and check this one. Solve this one. We're going to add 5 to both sides. We get 3x is less than 3. When we divide, we get x is less than 1. So that's our other solution. And now on to graphing it. If we graph it, we have a 7/3, which is 2 1/3. If you were to divide that out, you get it 2.3 repeating. So we're going to just say 2 1/3 over here. We know it's open circles because we don't have any and or equal to lines down there. So we know it because when this is alone, that's when you determine if it's and or. So we know it's an or. So we're going out this way. So how you check is, there's two ways to check. If you check the actual numbers that you got when you did the solution, you should get the same thing on both sides. So let's just check this 1. If I put a 1 in here, 3 times 1 is 3, minus 5 is -2. The absolute value of -2 is 2. When I multiply that by a -2, I get a -4. When I add 10, I get a 6. 6 is equal to 6. I want both sides to be equal if I put this number in. But let's say I shaded wrong. I saw up here that it was a less than, and I said, oh, that's an and, so I shade in between. If you picked a number like 2 and you put it in there, you should get a false inequality. So let's do that. If we put a 2, so 3 times 2 is 6, minus 5 is 1, the absolute value of 1 is 1, times -2 is -2. If I say -2 plus 10, I get an 8, and 8 is not less than 6. So if I had shaded here and checked it, then I would know I had shaded wrong. So keep that in mind. If you check something out here, you should get a correct inequality, and if you check the actual numbers that you got in your solution, you should get the same thing on both sides. Well, let's try this one. This one has a fraction. So to get rid of the fractions, hopefully you remember, we would multiply by the common denominator. So we're going to multiply everything by 7, and we cancel first. It's okay to divide. When you have division and multiplication, those have the same priority in the order of operations. So it's okay to divide first. 7 divided by 7 is 1, and then 1 times this is just the absolute value of 2x minus 5, which now is less than 21. And now we're ready to write our two equations. So we have 2x minus 5 is less than 21, and then we have 2x minus 5 is greater than -21, because left side stays the same. We switch this inequality sign and the sign of our number, or sometimes it's an expression. Then we're going to solve. So we're going to add 5 to both sides. We get 2x is less than 26. When we divide both sides by 2, we get x is less than 13. In this one, we add 5 to both sides. We get 2x is greater than negative, let's see, 20. Let's see about that. No, not 20. My mistake. 16. Negative 16. And when we divide both sides by 2, we get x is greater than negative 8. So these are our solutions. Now we want to graph. So when we graph, we get negative 8 and 13. We know that they're open circles, and it's an or. I'm sorry, it's a less than. It's an and. So we would shade on the inside. And again, we can check it. 0 is easy to check. Let's check 0. If we put a 0 in there, 2 times 0 is 0. Negative 5. Plus negative 5 is negative 5. The absolute value of negative 5 is 5 divided by 7 is not even 1. 5 over 7 isn't even 1, and yes, that is less than 3. So again, you can check your numbers. You get the same thing on both sides, or you can check something in your shaded area to make sure the inequality is correct. Good luck solving absolute value inequalities. M squared, signing out.